He is a professor in the Department of Information Science and Technology, Anna University. Her area of specialization is computer architecture and networks. One of her special interests is Indian language technology systems. She is actively involved in research in all the areas and has over 50 publications to her credit. She has about 25 years of experience covering both industry and academics.
Welcome to the UGC lecture series in computer science. We are looking at a series of lectures in computer networks. The topic we are looking at broadly is application layer protocols, and today we will be looking at details of the HTTP protocol. HTTP stands for the Hypertext Transfer Protocol, which is used in the World Wide Web. We will be looking at how the details of the HTTP protocol in terms of the different connections supported, persistent and non-persistent connections, the different request and response message formats that are used, use of cookies and caching. So, to do a quick overview of the HTTP protocol, it is a request response protocol and it is web's application layer protocol. It is a client server model. So, you have clients running on different machines. A PC could be running, a Windows PC could be running Explorer. Now, Explorer happens to be the client protocol, client program here, and a Mac could be running a Navigator, that becomes the client program here. Now, these client programs can talk to a server. The server would be running, for instance, the web server, the Apache web server, and these client programs, processes running on these individual machines can send HTTP requests to the server and get back the corresponding HTTP response. So, we say it is a request response protocol. So, the client is the browser, as we said, which requests, receives and displays the web objects. The server is a protocol that is a program which serves the requests which are coming in from the client. Now, when we talk of HTTP connections, we talk about non-persistent HTTP and we talk about persistent HTTP. So, in non-persistent HTTP, at most one object is sent over a TCP connection. Remember that HTTP protocol runs on top of the TCP protocol. So, a TCP connection is to be established for the data that is to be transferred by HTTP protocol. So, in a non-persistent HTTP, for every object that is to be retrieved, a separate TCP connection needs to be established. The HTTP 1.0 version uses the non-persistent HTTP mechanism. The persistent HTTP protocol, on the other hand, uses the same connection to retrieve multiple objects. So, we say multiple objects can be sent over a single TCP connection between the client and the server. HTTP 1.1 uses persistent connections as the default mode. So, if you do a quick comparison between the non-persistent and persistent HTTP, suppose I have a file which is to be retrieved, which has 10 different objects which are there in it. Those 10 objects could be 10 different image files which are present, JPEG files for instance. So, in non-persistent HTTP, what I would need to do is, I would first need to open up a TCP connection, retrieve the base page, close the TCP connection, look at the TCP page, identify that there are 10 different objects that need to be referenced. So, for each of those objects, you have to open a separate TCP connection, retrieve the object and then close that connection, and then all these objects that have been retrieved will be displayed by the browser or the client. Okay. In persistent HTTP, on the other hand, what we would do is the same TCP connection would be kept open and the different objects would be sent using that same TCP connection. So, in which case this job of opening and closing connections, that is much less in the case of persistent HTTP protocol. Initial versions of HTTP, that is 1.0, use the non-persistent HTTP protocol, whereas current versions 1.1 and so on, they use current version which is 1.1 uses the persistent HTTP protocol. In persistent HTTP, again we have two options. One is persistent without pipelining and the other is persistent with pipelining. So, if you look at persistent HTTP without pipelining, let us look at what happens here. The client will issue a new request only when the previous response has been received. So, that is, as I said, there is one TCP connection that is established. So, if we go back to our same example of 10 different objects being retrieved. So, first I open a TCP connection, get the base page, I do not close the connection, I keep the connection open. Now, in the base page I have identified that there are 10 objects to be retrieved. So, for each object I send out a new request, same TCP connection, I send out a new request and I get back the response for the first object. After I receive the response for the first object, then I send out the request for the second object. So, sequentially you will be sending out requests for each object and receiving the responses. The new request is sent only after receiving the previous response. So, this is called as persistent HTTP without pipelining. So, what is the time that will be taken for retrieving the different objects here? Initially, you need to set up a TCP connection, one RTT for that. Then you have to retrieve the original base page, that will take up another RTT, one round trip time for that. Then for each object that is referenced, one RTT will be taken. So, if there are 10 objects referenced, it will take another 10 RTTs. So, 1 plus 1 plus 10, at least 12 RTTs before the page is displayed to you. This is what happens in persistent without pipelining. In persistent HTTP with pipelining, which is the default in the HTTP 1.1 version, the client sends requests as soon as it encounters a referenced object. That is, coming back to our example again, where we have 10 different objects to be retrieved. First, a TCP connection is established, you get back the base page, 2 RTTs for that. After receiving the base page, you realize that there are 10 different objects which are referenced in that particular page. So, all the 10 pages, right, all the 10 requests for these 10 different objects are all now sent immediately. That is, as soon as the client identifies a referenced object, it sends out a request for that. So, all these responses can come back immediately. So, it would be almost as if a single RTT is used for retrieving all the pages, all these different objects which are there in this particular page. So, in one RTT, I would get back all the referenced objects. So, total time that it would take with pipelining would be 1 RTT to establish the TCP connection, 1 RTT to retrieve the base page, and 1 RTT to retrieve all the 10 objects which are referenced. So, this is persistent with pipelining. You can clearly see that persistent with pipelining will give you the best response time. So, which is why persistent with HTTP is the default mode in the HTTP 1.1 protocol. So, now coming to take a look at the details of what these request and response messages actually look like. So, let us take a look at details of them. So, as I said, there are 2 types of messages, a request message and a response message. Request message has a particular format, response message has a different format. Now, what is very interesting about most of these application layer protocols, including the HTTP protocol, is that the messages are all in ASCII and they are kind of human readable format. So, you can look at the message and just find out what is exactly there, read what is there in the message directly. So, if you look at the HTTP request message, it basically goes like this. You will have something like a GET followed by some URL that is specified, that will be followed by the HTTP version that is used, HTTP/1.1 in this case. Then you have a host line which says, which is the host that you are trying to retrieve data from. So, www.someschool.edu for instance. You specify the user agent. The user agent here refers to the client program that is sending this request. For instance, if it is coming from a Mozilla 4.0 version browser, then that is what will be specified here. And then we talk about the connection, whether the connection has to be kept open or the connection has to be closed. Remember that if the connection is closed, it means that after retrieving this object, the connection will be closed. It corresponds to the non-persistent mode of operation. But if you want the connection to be kept open, then you would specify it as connection and you would say connection should be open. Then there is another line here, header line here, which says accept language :fr. For instance, there are different languages in which the web page may be displayed to you. So, if you have a specific preference for a language, that could be specified as accept language :fr. For instance, in this case we may be trying to get it in French or whatever. Okay. So, these lines and a few more like this, they form what are called as the header lines. After this header lines, you would have the body of the message. So, when you have a GET message, typically you are only sending a GET, you are sending a request for something. So, it only consists of these header lines and it is terminated by putting a line feed, a carriage return and a line feed. And there is an extra carriage return line feed which indicates the end of the message. So, you will be followed by 2 carriage return line fields after the header lines, and that will terminate the request message that is being sent. So, in the request message, this first line here, the very first line, that will define what is the method that is being specified in the request message. In the request message, I could have different commands which are being specified. I could have a GET command, or it could be a POST command, or it could be a HEAD command. A GET command is a command which tells that I need to get this object. You are telling the server to send you that object. A POST command indicates that you are posting information. In one case you are retrieving information, POST command you are posting information. A head command on the other hand says that you want to only retrieve the header information, you are not interested in the data portion. So, that is the those are the possible types of request commands that could be there. So, typically if you look at a request message, it will have this format. It will start with one of these lines which says what is the message, what is the command that is being specified. It will be followed by the path of the message, it will have this information about the protocol, and then different header lines. Each header line will start with some keywords followed by a colon followed by some information. So, this will be interpreted by the server and the appropriate response will be sent. So, if you look at the general format of the HTTP request message, it looks like this: method space URL space version followed by a carriage return line feed, that is the next header field has to be on a new line. So, a carriage return line feed basically brings you back to the next line. So, next line will be followed by header field name colon value carriage return line feed, many such header fields, all of them in the same format followed by a colon followed by some value and terminating with the carriage return line feed. Then there is a carriage return line feed which terminates this entire set of header lines. This is followed by the entity body. Now, here again if it is a get message, this entity body will be empty, but if it is a post message where you are posting some information to the server, then that post whatever message needs to be posted, that would be present as the entity body. So, this is the overall general format for a HTTP request message. So, when you are uploading form input, for instance I just said you could be getting data or you could be posting data. Now, when you talk of posting data, there are actually two methods available or two ways available for posting information. One is of course as I just said, using the post method. So, in this case the web page often includes when the web page often includes form input, the input is loaded to the server in the entity body. So, if I go back here, if I had a post message here, the information that needs to be posted would be available in the entity body. The other is a URL method, in which case it uses the get method, but the input that needs to be sent is uploaded in the URL field of the request line. For instance, you could have something like this: www.somesite.com/animal search monkeys and banana. For instance, this information could be a search command that is being posted, that is, there is some information that is being posted. For instance, we are doing a search. So, this information could be embedded in the URL field of the request line itself. So, I can use a get method itself to also post some information, to upload some information to the server. Okay. So, uploading input to the server can happen by means of these two methods. One is use the post method, the other is use the get method, but specify the information you are looking for in the URL of the get method. So, these are two different options for posting data to the server. Okay. Now, if you look at the other different method types which are available in both versions of the HTTP protocol. So, as I said, you can have a get method, a post method and a head method. Now, the head method asks server to leave the requested object out of response and just give the header back. HTTP 1.1 on the other hand again has these three: get, post, head, but in addition to that it also has another method called a put method. Now, this uploads file in the entity body to the path specified in the URL field. So, you can kind of put it in a particular location. You also have a delete method which is available, which deletes the file which is specified in the URL field. So, these are additional methods supported in the HTTP 1.1 version. Now, if you look at the HTTP response message, we just took a look at the request, now we will be looking at the response message. If you look at the HTTP response message, let us look at what it has. Again, it will have a set of header lines followed by data. Remember, the response typically is a response to a get command, so which means that the response will consist of data that is being sent to the client. So, if you look at the message again ASCII text, so you can read all the header lines and understand what is the content being specified here. So, the first line will be a status line. Okay. The status line will consist of what is the protocol that is being used. So, HTTP followed by the version 1.1 or 1.0, and this is followed by a status code and that is followed by a status phrase. So, 200 OK indicates that your request was processed successfully, and what follows is the information corresponding to that. So, we say connection close. Remember, our connection indicates whether you are closing the connection or keeping the connection open, corresponding to persistent and non-persistent HTTP. Persistent, you are going to keep it open, non-persistent you will close the connection. This is followed by date, the date is specified, then you specify the server which is giving you the response. So, it could be Apache 1.3.0, last modified date, the date at which this particular file was last modified, this information is specified, followed by the length of the content, how big is this content and what is the type of content, you could say text / HTML, this is followed by data, right. So, this is how a HTTP response message will look like. Now that we have taken a look at both request and response messages, we just take a small break before we come and continue with the other details of the HTTP protocol. Welcome back after the break. We are just looking at HTTP request and response messages. Response message we just said will consist of the status line and the status code which specifies whether the request was successfully executed or not. So, now we will go into the details of this response message. So, as I said, the first line, the server client response message, the first line is the basically consists of the status code, a few sample codes that are typically encountered. You have this 200 OK which indicates the request succeeded and the requested object is present later in this message. Another one that we also find is 301 moved permanently. Now, often you will find that you get a message which says moved permanently. This basically says that the requested object moved and the new locations is specified later in this message. So, normally it will be specified using a header which starts with location followed by colon and then the location would be specified over here. This is another message that is possible. Other status codes that you may have, that you may get are 400 which would be a bad request. This says that the request message is not understood by the server. So, maybe the request got corrupted or whatever and so the request message is not understood by the server. 404 not found, I think this is one of the most commonly used error messages that we encounter. So, the requested document was not found on this server. So, HTTP gives you a message saying 404 it is not found. 505 HTTP version not supported, this is yet another status code that you could obtain. So, like this you have some different status codes which could be obtained. Now, what is very interesting about HTTP is the client side protocol is that you can actually type in these different header lines and directly talk to the HTTP server. That is, you could act as the HTTP client sending out all these messages. So, I will just tell you how that could be done. So, what you need to do for that is you can just telnet to your favorite web server. Okay. So, you say for instance telnet, you specify the web server that you want to connect to and specify the port number 80 which is the default TCP HTTP server. So, you say telnet web server followed by the port number 80. So, what this does for you is this opens a TCP connection to port 80 which is our default HTTP server port at this particular website, okay, on this web server. So, anything that you type now will be sent into the port 80 at the cis.poly.edu or whichever website you have specified. So, which means you are actually now connected to the server, the HTTP server which is running on that particular machine. Okay. So, now all you need to do is type in your HTTP request messages. So, you can do something like get slash tilde ROS slash then there is a space HTTP slash 1.1 specify the host colon cis.poly.edu. So, and then you specify a carriage return twice, that is you hit return twice, that completes this message. That is, now we are sending a simple request message which only has two header lines, a get line and a host line, that is sufficient. So, by typing this you have sent your get request to the HTTP server. Now, this request once it goes to the server will elicit a response from the server and the response that you get will be typed out onto your terminal. So, you can get back the response message which is sent by the HTTP server. This is an easy thing that you could try out to get a feel of what this HTTP request response actually looks like. Okay. Now, we just said that the HTTP protocol is considered to be a stateless protocol, that is, it does not maintain any state information, but often many of the websites would like to have some information about the request that you have made, so that they could either provide you some better services or use it for security purposes or for whatever different reasons. So, how is it that you can use a stateless protocol like HTTP and still try to keep track of something that is happening on the client side? So, this is done by means of what are called as cookies. So what the user does is, what the server does is, it tries to maintain some state about the user, about different clients, by means of this item called cookies. So let us look at what we mean by this cookies. So as I said, many major websites use cookies. So what exactly is a cookie? This cookie actually consists of 4 components. Okay, they actually go like this. The cookie header line, basically you have a header line called cookie, which is sent in the HTTP response message. That is, when a client sends a request to a server and the server wants to make sure that it is able to keep some information about this particular client, what it does is, it does not maintain that information in the server. Instead, it requests the client to keep something called a cookie in that client, and then subsequent requests which come from the client will have this cookie information being sent back to the server, so that that cookie information can be used by the server to keep track of the previous state or previous requests of this particular client. So we will see that these are what you find as the components of a cookie process as such. So if you look at what is happening here, the 4 components of a cookie are like this. There is a cookie header line which is there in the HTTP response message. Similarly, there is a cookie header line in the HTTP request message. We will just look at what is the difference between these two. And the cookie file is kept on the user's host and is managed by the user's browser. And there is a back-end database at the website which uses this cookie information to retrieve all the details that are required, that are specific to that particular user. So, you use the cookie to index into the database and get all the required information. Okay. So, this is how cookies are used to maintain user server state. Okay. So, for example, let us say we are looking at a particular scenario where a user accesses internet always from the same PC. Okay. So, she visits a specific e-commerce site for the first time. Now, when initial HTTP request arrives at the site now will create a unique ID and create an entry in the backend database for this ID. So, you can see what is happening here. For instance, the client here is sending a usual HTTP request message, but what the server does is, it creates an ID for this user and makes an entry in the backend database. Say for instance, it creates an ID called 1678 for this user. So, in the response message, what it does is, it sends the usual HTTP response, plus there is a new header line which is added which says set cookie, and it specifies this ID which has been created 1678. This is the cookie number. So, what happens on the client side is, the client side now which has a cookie file takes this information of 1678 and says, for this particular server it has a cookie number. So, it says that the cookie number is 1678. If it already has some other information here, say eBay 8734, this is a cookie set by some other website, say eBay. Now, it is a request which was sent to Amazon for instance, and Amazon has given a cookie number 1678. So, the cookie file now has one more entry which says Amazon:1678. Now, so this is something which has happened. Now, what happens is 1 week later, so let us say for instance, this client is now sending a new request to the server. So, now what I will do is, HTTP now will send the usual HTTP request message, plus it gives the identification of who this particular user is. So, it will say cookie:1678. So, it says, identifies itself that this request now is coming from this cookie 1678, which is an identification of this particular user. So, now what the server will do is, it can take a cookie specific action and it can send a HTTP response message accordingly. 1 week later, again if you do the same thing, what would you do? Again the cookie information of 1678 would be sent here, and again cookie specific action depending on, for instance, let us say the person purchased a particular set of books in networks. So, network related information may be sent as part of the response message as well, in addition to whatever message is being requested. So, this is how clients and servers use cookies to keep track of information. So, all the information the server needs is actually maintained in the backend database. The cookie actually serves just as an index into this database. So, that is how it is handled. So, what is it that cookies can bring us? Authorization, shopping carts, recommendations, user session state, web mail and so on. All these can be provided by means of cookies. They also allow, another thing we need to look at is how is privacy affected by cookies. Remember that cookies permit sites to learn a lot about you, about the user. So, you may supply name and email to sites. So, this information could be used by the websites. So, search engines use redirection and cookies to learn a lot more about the user's request, and advertising companies obtain this information across sites. So, you will find that often you get advertisements which are very much suitable to the kind of request you are making. This happens basically because of cookies. Okay. In a sense, it is a violation of privacy, but still it gives you a lot of useful information. So, that is how the cookies are used. One of the important aspects of the HTTP protocol is the use of web caches. So, often we find that whenever we make a request, some responses come back very quickly, some responses take a long time to come. Typically, requests to the same websites normally are responded very quickly. Now, how does this happen? What actually happens is that the request does not really go to the server, instead it goes to something called a proxy server, and this proxy is located typically much closer to you. So, your response is actually satisfied by the proxy server itself if the request is the same request that was just made a few minutes earlier or just a few seconds earlier and so on. So, when you have web caches, let us look at what is the architecture that is actually used. So, if you look at this picture here, you have different clients which are connected by means of a proxy server to the actual server. That is, typically at the boundary of any institution, you will have something called a proxy server. So, all client requests are not directly sent to the server, but they are actually sent only to the proxy server. Now, the proxy server maintains a cache of all the responses that are received. So, what the proxy server will do is, when it receives the first request, it will forward that request to the actual server, what we call as the origin server. Now, this server will send back a response. The response now will be cached by this proxy server, and the response will also be sent to the client. Now, subsequently, if another client sends the same request, what the proxy server will do is, it will check in its cache if this is available. Since it is available, the response can be sent back immediately from here, right. So, this is how this client will get back a quick response. Even this client again, if he sends back the same request, again will get back a quick response because it is already present in his, it is available in the proxy server, and the response comes back immediately. So, this idea of a proxy server or web caches is used extensively in the HTTP world in order to make your response time faster. So, the goal of proxy servers basically is this: you have to satisfy client request without involving the origin server. So, user sets browser such that the web accesses are done via a cache. So, the browser sends all HTTP requests to cache. So, the object, if it is there in the cache returns the object, else the cache requests the object from the origin server, then returns the object to the client. If you look at more details of web caching, the cache actually will act both as the client and the server. Okay, remember, it is acting as a client server with respect to the client which requested it, and it is acting as a client with respect to the origin server. Now, typically caching is installed by the ISP, university, company, or residential ISP. Okay. Now, why do we use web caching? As I said, it is to reduce the response time for the client request and reduce traffic on an institution's access link, and also it is useful when you have P2P file sharing and so on. One important aspect of this proxy server is that what happens if the server has got some information which is actually updated at the server, then the response that is giving back is not up to date information. So, this is normally taken care of by means of what is called as a conditional get. So, what we do here is, a conditional get is a header file, basically a header command which is used in the HTTP request message, which says you send me this data only if it has been modified since a particular date. Okay. So, do not send the object if the cache has up to date cached version, send it to me only if it has been modified. So, the cache therefore sends a request which says send me this file if it has been modified since this date. So, this if modified since is a new header that is added, and the server's response will be like this: the server response contains no object if the cached copy is up to date. So, all it sends back then is a response which says not modified, in which case the cache knows that it has the up to date copy, so it can send it back immediately, else it will send back the actual file. So, using this combination of this conditional get, if modified since, and these kind of headers, you are able to effectively improve the response time. So, this is basically how HTTP has evolved to provide us very good response time. So, to summarize, what we have looked at today are the details of the HTTP protocol. So, we have looked at persistent and non-persistent connections, and in persistent connection we have looked at pipelined and non-pipelined connections, formats of the request and response messages, use of cookies, and how the caching has been established and how caching has been used in order to improve the performance of HTTP protocol. A few questions for you. Question number 1, which is faster, pipelined operation or non-pipelined? Why? Question number 2, what are cookies? Question number 3, what is the purpose of the conditional get method? Question number 4, what is a web cache? Question number 5, why is web caching used? Thank you.